Hello, today we're going to learn how to find the electric field with lines of charge. Before we did point charges, and that's easy. You just plug it into this little equation right here and out pops our electric field vector. But with lines of charge, it's a little harder. How would we, for instance, find the electric field at this point with this line of charge right here? Well, I'll show you in 5 easy steps. Step 1, we got to define our axes and coordinate systems. I used a Cartesian coordinate system with point P lying at the origin, a distance d away from this charged line, and the charged line is a length of L. Step 2, we find the separation vector. This is our separation vector equation. We know point P is at the origin, and the source, aka the line, is a distance negative d away with y, because the line goes from negative 1/2 L to 1/2 L, so it's more a variable than a constant, and that's our separation vector. Therefore, step 3, we're going to use a linear charge density, and we use this because it's easier to integrate over lines versus over a charge. So we know the linear charge density is the charge over the length. We can rewrite it this way, and that means you take the derivative of both sides, and a tiny chunk of charge is equal to the charge density times a tiny chunk of length. Step 4, we set up our integral. This is the general form, so if we add up infinitely over arbitrarily small chunks of charge, this is what it'd look like. But instead, we're going to make the substitution, so instead of dq, it's lambda dy. All this other stuff is just fancy ways to write the separation and distance vectors, but it's more syntax than anything else. And you set up the bounds and you make the substitution. Step 5, you solve using your favorite technique. Some final notes right here. Just know that usually the distance will be given and the length is not constant. Thank you.